Welcome to a presentation of structural detailing software ProStructure developed by Inventive Engineering and Technology Pvt Limited Pune. This software is developed in-house and we are presently using this software for giving structural detailing services to various clients. In future, we are also planning to make this software available on cloud so that the user can directly generate the GA and fabrication drawings online by uploading a file generated from design software such as STAD. In any process plant, the structural designing is done using some design software such as STAD. After the designing is completed, the major time consuming task of making the GA drawings and the shop drawings is carried out. This always becomes a bottleneck considering the urgency of the project. We have exactly targeted this activity and developed this software for automatically creating connections and generating all the drawings for the required structure. Our present module mainly covers all type of grid structures and we are in process of developing software for other structural items such as staircases, trusses, gratings, railings, trestles, etc. Now let us start with the actual presentation of the software. So there is an icon ProStructure, click on that and then you log in using your username and the password. Now after logging you can actually create one new project or you can open an existing project. Now right now there are some few projects which are already there. I am opening one of them. So when you open a project or when you create a new project, you have to fill this information like what is the job code, plant name, client name, consultant name, location. And the first step of starting a project is that you have to create different types of connections in the project. So what we have developed is that we have developed a connection builder and connection application. So you can, using this particular module, you can create different types of connections. Like for example, if I go to this beam to column flange joint connection, then there are various connections options which are possible in the software. So you can say select a top cleat and the web cleat and the seat cleat, any combination of that, and then you can create a new type of connection here. So using this particular option or feature, you can create number of types of different connections here. And then after the connection types are designed or configured in the software, you can actually apply those types to different types of members. Like for example, if you go there and say again select this beam to column flange joint, and you can select that what is the main beam size or main size and the child size. So you can select any size from the available options. We have got all the libraries of different types of beams and then channels, then angles from different standards. So you can select say for ISMB 450 to ISMB 300 and then enter the different types of parameters which are required to be adhered to that particular type of connection. So here what we have done is that, like for example ISMB 450 to ISMB 300, we have given here we have used a web cleat of ISA 75-75-8 and we have given other dimensions which are required for that particular connection here. On similar lines you can create different types of connections like beam to beam, then beam to column flange, beam to column web, then bracings connections, and give all the parameters or the values of different type of parameters here using this particular module connection builder and connection application. After this process is done, then again you go to the main project screen, and now what you can do is that you can add number of structures in this particular project. Like for example, now presently we are working on a cement plant packing plant project where there are different types of structures like say packing plant, then the wagon unloading, then back filter supporting structure. So in the same project you can add any number of structures inside this tree. Now there is in this demo project there is only one structure. Now when you add one structure, it means that you have to add the name of the structure, what is the reference level and the unit for that particular structure. And since it is a grid based structure, you can add say what is the front wall bay details and the side wall bay details. So what is the X spacings and what is the Y spacing and what are the different floors in that particular structure. So you can add the top of section, the TOS values for that particular structure. So this is the basic data entry what you have to do for each and every structure before actually going to the CAD or before actually going to create the 3D model and the drawings. So after basic data entry is done and after building all the connections in the library of that particular project, now you can shift to AutoCAD. Now I am opening AutoCAD through our software. The starting point of the 3D model is of course a single line drawing, which you can see right now on the screen. Now this particular single line drawing is basically an output of STAD file. So if the designing of this particular structure has been already done using STAD, then you can generate a DXF file from STAD which looks similar to this particular single line what you are seeing right now. Now if you have not done the designing through STAD, then also you can create a this single line model using regular manual AutoCAD commands by giving a line and writing a text on that particular line saying that this is say ISMB 200 or ISMC 150 and all that. So basically the starting point for a 3D model is a single line drawing either from STAD or manually created using basic AutoCAD commands. Now this single line drawing is a 3D drawing. Like for example, if you see this orbit view, you will notice that it is a 3D drawing. It is single line, but it is a 3D. In 3D, it has got all the dimensions. Now, this particular drawing needs to be first converted to actual structure. So, wherever there is ISMB, wherever there is ISMC and bracings and all that, first it has to be converted to a 3D model. So, basically, if you notice at the top, we have got the menus. So, apart from AutoCAD menus, we have got all ProStructure menus on the top. So first is that you have to align the STAD model. Now in some cases what happens is that the STAD model comes with different types of units. So a STAD model can be in meters or it can be rotated in different orientation. So this particular module you can use for making that model converted to regular millimeter units and also required to be oriented in proper way. So that this option you can use on that. After the STAD model is aligned, now next step is that you convert this single line to a 3D model. Now I am clicking on that. Now it is asking different options, like for example if a STAD model is done TOS based or it is CG based, what are the bracings orientations. So those options at the bottom of the screen you can see, and using these options then you can make that model single line converted to a 3D model. So it is asking whether you want to join the linear members. In STAD actually the members are coming node wise, so they are not joined together, so the linear members are not joined. So this particular option enables the user to join those members also, and there are few more options, column orientation and all. So right now you are seeing that the single line is getting converted into a 3D model. Now while it is getting converted to 3D model, it is also joining the linear members and breaking the beams and all at the column locations. So that process is also done by the software. It is also aligning the CGs of different bracings based on whether we have done TOS based modeling or the CG based modeling. So that all the activity is done by the software. And now you can see the single line has been converted to actual solid model. If I shade this particular model, now you can see that it is all the different types of bracings and beams and columns, they have been converted to their actual sizes. Now after the single line is converted to 3D, you will notice that it has just converted all the members from single line to 3D. There are no connections right now in this model. So if you see like column to beam or beam to beam, they are just all the members aligned to the center lines. There are no connections built. So we have got different types of connections utilities or connection building in the software. I will just show you one by one. So there is column to beam joining. So right now there are no column to beam joining done, but if you notice now I am giving different types of inputs for making the column to beam joining. Now what software is doing is that it is finding each and every joint where a beam is joined to a column either on flange or on web, and whether it is also having different types of bracings at that particular connection point. And based on the connection builder or connection library that we have built at the project level, the software is generating all 3D connections at that particular point. Now while generating the connections, it is also taking care that the member or the beam is getting shortened by the distance that is specified in that connection library. So the reduction of the beam and the connection building, that both the processes right now they are happening. At the same time, if there are bracings at the same connection point, the software also creates different types of gussets, finding out the length of the welding length and the distances of the gussets from the member and all that. So that everything is done by the software while this process is going on. So now you will see, now if you see this particular point, a red web clit has been generated or has been created by the software, and this beam has been reduced by that particular flange and the distance that we have given in the correction library. So wherever now there are column to beam connections, the software has generated those, and it has completed that particular process. Now after this column to beam is joining is done, now the next step is to generate the beam to beam joining. So for beam to beam joining, again if you notice, now right now all the beams are interfering with each other. There is no connections, there are no connections built for beam to beam joining. So there is one more option in the software, beam to beam joining. So click on that, give few options or few inputs, and then software will take some time to find each and every beam to beam join, and again based on the library or the connection builder that we have used, it will generate all types of different beam to beam connections, including the bracing, gussets and all that. Now that process is happening. It takes some time, around say half a minute or something, to actually generate those connections, but right now it is finding each and every joint where the beam is joined to another beam. There are different types of logics inbuilt inside the software to find out the length of the gussets and the distances of gussets from that particular beam, so all that safety distances. Then based on the bracings, holes, distances or rows and columns, it finds out the exact size of the gusset. So that all the logics have been built inside the software, and now using all the logics and finding out all the different types of beams, joints, it is generating the connections. Now there is also utility in the software that if by chance you have missed some connections in the connection builder, then after this process is done, the software will show you a message saying that these connections details are not there in the library. So what you can do is that you can revisit the connection builder and input those type of connections, and again generate the beam to beam connections here. So those validations and those logics are also inbuilt inside the software. So now it is creating the beam to beam joint. Now based on the number of connections which are there, it will take that much time to generate the connections, but the whole process is automatic. The user doesn't have to find any connections and apply manual data to it. So it is almost done now. I will just zoom after this process is done. I will just zoom and show you that what types of beam to beam connections the software has done. So you can see now 212 beam to beam connections have been done. So now you can notice that there are all these red clades have come, which are beam to beam joining clades. At the same time, I will show you that there are few bracings also generated by the software, the gussets, bracing gussets. So if you notice here, there is at the same point one beam is joined to the beam, and also there are few bracings at the same point. So the software has generated a white this gusset in that particular joint. Now in this way, the beam to beam and the column to beam joinings have been done by the software. Now after this beam to beam and column to beam joining is done, the final step is to generate the gussets, which are only for bracings. Like for example, there are few bracings where they are joined to either beam or column, but there is no beam or column joining at that particular point. So that particular connections are built by using this particular option, create bracings and gussets. So now the software will find only the points where the bracings are joined together, or bracings are either joined to the columns or beams, and it will find out the gussets dimensions from different logics and the connection building library, and then it will generate the bracing gussets at that particular point. So that process is happening right now. This is the final stage. So there are three stages. One is to generate the connection of column to beams, the second is to beam, and the third is to generate gussets for bracings. After these three stages are done, then the model is almost done, and then after that 3D model is done, then you can generate different types of 2D outputs such as GA drawings and the fabrication drawings that we will see later after this 3D model is actually generated by the software or completed by the software. Now it is generating gussets for different types of bracings. It also generates the gussets which are there for the cross bracings. So there are few places where the bracings are crossing with each other. So there also there are logics by which the gussets are generated by the software. So now it is doing that cross bracing. You can see at the bottom the progress of that process, what is happening through the software. So it has created 136 bracing gussets right now, and now the cross bracings are getting generated. So now the final model is ready. Now if you notice, now it has generated all types of connections. I'll just zoom it somewhere. So now you can see here these gussets are for bracings. Then there are column to beam joining. So the web cleats have come, the beam to beam joining web cleats have come, and the gussets are developed by the software. So right now it has developed or generated all types of joints which are there in this particular structure based on the logics and the connection builder or connection libraries that we have built inside that particular project. So after this 3D model is generated and the connections are built, we can generate various outputs from this particular 3D model. So major outputs are the all different types of GA drawings like plans, elevation and side views, and then the shop drawings for beams, columns and bracings. So all these can be generated by the software automatically. First we'll just see how the plans can be generated. I'm clicking on generate plans for all TOS. Now we have already given the data for all floors, the TOS values of that. Based on those TOS that we have entered, the software will find out all the members at that particular TOS, and based on the number of floors it will generate those many drawings for that particular 3D model. Now that process is happening right now. It is finding out each and every member for that particular TOS, the first TOS, and then it will generate a complete GA or the plan view for that particular TOS. Now there is inbuilt module or inbuilt feature in the software where the different types of tag numbers are assigned automatically to different members. In the sense, the software finds out each and every member which is unique in the sense it has got a unique dimension, unique size, then the unique clits and unique gussets and all that, and then it assigns a unique number to it. So it finds out all the members inside the model and assigns the tag numbers to all beams, all bracings and all columns. So that process first happens before generating any output, and those tag numbers are reflected in this particular GA, and also based on those tag numbers the shop drawings are generated. So now it is generating a plan view for one TOS. Now as I said, based on different number of floors, it will generate those many drawings. That process is happening right now. We'll just wait for that process to complete. So it is a second level, third level. Okay, so it has generated all the plans now. We'll just zoom now and see. So it has generated 3 plan views now. We'll just zoom to one. So right now you can see it has drawn all the members with all its plates, all the gussets, holes. It has also given the member size and all the tag numbering, and it has created a grid based on the grid details that we have given. So these are the plan view it has generated for that particular TOS, then the second TOS, the third TOS. So based on number of floors, it will go on generating those many drawings for all the TOS in that particular 3D model. So on similar lines, now as we have generated the plan views, we can generate the elevations and side views and all that. I will just open those drawings which are already generated. So these I am showing elevations right now. And of course the right hand side views. So you can see now these are the elevations which are generated by the software automatically. So you can see now it has generated the elevations by again showing the bracings, even the packing plates have been put by the software, then the numbering and the size, the dimensions, so that everything is given, and based on the grid details that we have given, it has generated 5 elevations for this complete grid. And similarly it also has generated the right hand side views on the similar lines. So these are the 3 right hand side views. Maybe you can generate even left hand side views, or you can also have a facility of generating the elevations, plans or right hand side views based on whatever value that you give. Like if you want an intermediate section or intermediate plan floor, then that also can be generated by the software. So after all the GA drawings have been generated, again we can open the final model that we have done, and then there is an option for generating all the shop drawings for beams, columns and bracings. So you can click on this particular beam drawings, and then the software will start generating the beam drawings. All the beams it will actually put inside papers and sheets of different sizes. So it is calculating the scale automatically. It is also putting the different types of lengths and all. And also on the right side you will see the details of clids getting generated, the details of all the members with its weights, and all the detailed bill of material is getting generated. The software has inbuilt logics for putting the beams inside different sheets. So based on the lengths and number of clids, it finds out the optimum sheet size, the sheet scale, and also it finds out that how many members or how many beams to be placed inside a particular sheet. So right now it is generating the bigger members. So if it goes to smaller members, then automatically software will put different number of columns or 2 or 3 columns and put those members inside that particular sheet. So this process will go on based on how many beams are there in that particular model. So after this process is completed, you can see all the drawings of all the beams have been generated by the software. You can also notice that it has put all the beams as per their different lengths. So here there are more number of beams, and if you go to the higher or the more length beams, then you will notice that it has put 3, 4, 5 beams in one drawing. If you notice now also one more thing, it has given all the dimensions, all the numbers and all the clit details on the right side. So you will see all these details of the holes and basic gusset dimensions and complete detailed bill of material with all weight calculation and the plate sizes, the member sizes and all. Also it generates all the side member details, like for example if you see this is a B11 but it is joined to B18 on the left hand side and it is joined to B15 on the right hand side. All the cutting dimensions based on the data that we have built, the hole details and everything. So all the details which are required for fabrication of all the beams, the software has generated all these drawings now. Now based on the number of beams inside the model, number of distinct beams inside that particular model, the software may generate 20, 25 or any number of drawings, and the whole process is automatic. Maybe it take around say 5 or 10 minutes of time to complete this process, but all the drawings are getting automatically generated by the software. So the similar process you can carry out for generating the drawings of columns and the bracings. So these are the drawings which are generated for columns, with again all the details of the clids, the gussets, then different dimensions, even if it shows different types of sections at different levels to basically clarify the locations of the different members or different clids for that particular column. And then again the bill of material is generated with all the weights and all. So this is the columns drawing, and of course it also generates the complete bracings drawings. Again the packing plates are placed automatically based on the logics, and then the gussets and the bill of material is generated automatically. So now you can see this is a complete set of shop drawings and the GA drawings. The shop drawings for bracings, columns and beams, and the GA drawings like plans, elevation and side view. So starting from STAD or starting from single line, in just few hours of time you can generate all the connections, you can generate all types of fabrication drawings and the GA drawings. And as I said earlier, we are using this particular software now for giving services. So we take a project and we do all that particular STAD designing also that we do. But if the STAD is done by our client, then the client gives us the STAD file, the DXF file, and then we use this particular software to generate all the fabrication drawings. Thanks for watching. Thank you very much.